ITECH1102. Today we are going to discuss about that application layer mainly. So what are the 5 different layers? Application, transport, what was next? On the network, is it? Network interface, and then on a physical. Okay, so again it's easy to remember if you make a story out of it. How you open a computer? What you open first? Application. On application you type something, press enter, it goes on transport. Once it's transported, then it go on the network. Then on interface where it has to leave the computer and go in the form of electrical signals. That means it is in the physical form. So these are the 5 layers of TCP/IP model. Got it? Then we will see today what are the relationship between these 3 things. How we can actually use web browsers and FTP client. And also we can see the role of network protocol, common application layer protocols, and how data travels throughout that. First of all, with the application layer, what on application layer we do? We use the services. Any service, we use Google, Facebook, Maps, FTP file download sites. FTP mean file transfer protocol. Anything we need to download, any app, they are all working on where? On application layer. And then we have other layer of application is that when we are actually going to access any printer, any network faxes, networks attached storages like hard disks, or any other shared resources from other machines which are on the network, they are also on application layer. Okay. So now coming toward the categories of interaction, like what type of interaction are there between the computers? What are the different type of interaction between the computer? First of all, we can say that we as a client or google.com, we are going to click it. It means that we are getting information from the server of a Google. If we are using Outlook email, it's mean our server is Microsoft. So we can be like an email client, web client, FTP client, depends on the usage. So the role of, first of all, we will see the architecture of between client and server. So there are 2 computers or more than 2 computers. What is the role of client and server? So client on the one side is the person who is going to send something. Server is just in a listener mode because he is sitting in his office looking for the business. Client is the person who is knocking the door. Okay, so client is the one who always requests something. You request something, client sent you back. Client request something and server is actually going to give the response on that. You are opening a page, click it, you're receiving a message back. So you are getting that message from server. So that's a client server relationship. So client is a consumer of services and provider of services is whom? Web file, emails, or other are server. Server is the one who is giving you all those files back. So in case for us, what are the software we use to communicate with the server are Firefox, Chrome, Safari. These are the web browsers we use to connect to the servers. On the other hand, for the computers, for the servers, they are using softwares like Apache, Linux, Windows servers, okay, on Internet Information Systems. Those are the things which are used by the servers, because servers are actually getting the data of so many different clients. Client is alone. That's why maybe for him, he can use this browser only. But for the servers, they need the complete system to handle all the requests. Okay. Then we have a peer-to-peer architecture. Peer-to-peer mean like you are peer to each other, class, friends who work in a groups. So peer-to-peer mean they are equal roles. No one is bigger than other, not like a client server. So it means that in one class all are equal. So for them it's like a peer-to-peer network. where the relationship is like a where their resources are equal in sharing, and they can easily manage all those things. There are some advantages of peer-to-peer network and with respect to client-server network. For peer-to-peer network is good when you're using for a home network, because you know that at home all computers are at equal level. You are not making any one server. But when you are looking for a bigger network like a Federation University or ATMC, there are 50 or 100 of thousands of students are communicating. Then you need a network administrator, who is the person who has the computer as a server, who is actually managing everyone. So it means that when we are going to make a bigger system, then we use client server architecture. But if we are using a small business or a at home network, then we will make a peer to peer network, peer to peer architecture. Clear? Any questions? Okay. So, but again, one thing here, the word uses peer act as a server. Sometime in the peers as well. Let's say I say to you, like, rather everyone come to me, I want one person act as a like as a server, as a monitor. So it's easy for me to communicate. He's acting. He's not actually a server. So we need to understand that they are all peer, but sometimes we need to make one as a server as well in the peer-to-peer as well. But their all jobs are still equal. No one is greater and lower. Then we have a third one, host-based. Host-based. Okay, read through this line for a minute. I'm giving you a minute. Read through it, and then I will explain it. Any idea what is the difference between host and the other ones? What do you think? Hmm? Any idea? Anyone? What is it? What difference you can feel from the host, client server, and peer to peer?
The host is used in big companies for sales and purchasing. There so many clients or so many customers that are there outside. To manage them, host is used.
So remember that in the host relationship, host is connected with the like it is mainly used for the transactions like taking payments. FPOS machines on the Woolies or in Coles, you go and tap your card. Their job is to just take that very minimal information but do that transaction with the main computers. Normally in our case both computers are heavy, both are communicating at equal level because both have big size processor speed and everything. Here it's their job is to just take the data of customer to send to the main frame. Mainframe is a very super type of computer which has a huge calculation ability. So they have the power of that thing to communicate directly with the bank, to check you have a payment in the account, check that you have a right bank details or your those credit card details. Based on that, your that transaction is approved. So that's why the host based mean 99% things are with the host. With that small device which is used to tap the card, that's just doing a job of a very minimal data to take it. Yeah. So you can see the difference. Okay. So host base is like that. There is a kid of a dad who do nothing, who just want to take money every time, or he's a useless guy. Whereas peer to peer is one where two brothers are at equal level. Whereas client server is one who has a dad and their kid, but they are both responsible. That kid is responsible kid. So you can remember from that story. Okay, so these are three different architectures we have learned today. Okay, I understand that I'm going a bit fast because we are already late and you joined late. in the third week. So if you have any questions, definitely we will discuss next week. So please, from the next week when we come, I will ask you question about week 2, week 3 first, and then we move forward. I want to see how much you have uh, get that knowledge by yourself. Okay. Then we have cloud-based architecture. Cloud-based is one which is actually in our computer we are doing minimal work. Most of the work is done on other computers. Like right now, our most 10 years back, if we want to play a game, we want to buy a CD, put that CD in our computer in a CD-ROM, and you can see that there is no now CD-ROMs. Why? Because most of the things are shifted on cloud, and the reason is at that time we install it without internet we can play game, but nowadays games are on servers as well. Multiple people can play on that server connecting with their own computer to do that job. So they are all on cloud. So this type of architecture is now changed, and this is also one of them as well. So with the web browsers allow us to web view pages, complete order forms, pizza order, any census online, download programs, run web applications. These are all done on web browsers. We can do that. Email client, writing emails, file transfer services, any file want to transfer it, phone apps, they are all on application layer, including Facebook, Google, and those things. Now just have a quick look how this thing works. First you type it in google.com in a web browser. What it does, it send a request to a Google server. So as you click it, enter, your information is going outbound. What it is receiving inbound, display of that page what you have made a query. Then you click a link again, that outbound. When you click, it's outbound. When you get the answer, inbound. So this is what it's going on. You can see submit a query, you get a suggested link inbound. Then again going back and forth. And this is how we keep going on with the browsing, isn't it? Similarly for the FTP. FTP is file transfer protocol, where only files are transferred. These are the quite different type of work, which is where their job is to download only files from some servers, nothing else, no browsers, nothing other things are involved. And in that one as well, you put the address of the FTP server, FTP client request a connection, it will send a username and password, and it makes a connection straight away. In web applications, remember that with the network protocols, what is mean by protocol? Anyone? What is the definition of a protocol?
Set of rules to do something.
Yeah, set of rules, regulation to do something. For example, if I'm talking with you using a language with pronouncing some words in some manner, understand you that you understand that language. If I suddenly change my language to something else, by say I'm speaking the same, using the same voice, but if I change my vocals and it's totally different, you will not understand anything. It means if I am speaking English, I am using some rules. Due to that, you are understanding it. So language also a set of rules and regulations as well. If you're not following it, then means you are not capable enough to understand it. That's why for any language to be at their perfect level, it means that you are following the rules and regulations with 100% level. Then it means that you are understanding 100%. Make sense? So with that network protocols, web applications use what? HTTP protocol, hyper text transfer protocol. Always they use hyper text transfer protocol, whereas FTP use file transfer protocols. So for you people, it should be in your mind of those things very clearly, what every layer is doing, what their job is, what type of protocols are working on each layer. That helps you in your things. So these are some of the things which are done on the application layers on that. What is so okay. Is it stopped or what? Okay, that's fine. Is it working now? Okay. So now with this one, BitTorrent, NTP, POP, SMB, these are different type of protocol layers which work on different one, but they are all part of application layer. These one are some of the one are also your task of your lab as well, lab 3 task. Okay, and that one you will use do it. So what's the time now? 4:29. Okay, still we have time. Okay, role of application layer protocols. First of all, what we need to do is establish a connection between a sender and receiver. Okay. Second thing, how your message is structured. That's the same thing which I explained already. The message should be in some format. If I speak English, it should be in some proper format, then you understand. If it's not like that, it's hard for you to understand that thing. Then whatsoever the message is sent, and then see how it is handled. So these are the role of application layer protocols. These are all the jobs done by the application layer protocol. We'll see one example on that. So the rule is that one party is actually making a request and other is giving the option to say yes or no. Based on that, that working is done in networking. For example, you want to communicate with someone, they say yes, okay, that's fine. Then you are able to make a connection, and that's how you can make a communication on that. For FTP server, your username and password is shared. Once you know that username and password, you enter it. It gives you a connection straight away. So there is a very important thing to give you understanding here. We are talking here about FTP server. FTP server is a bit different from normal web serving when we click it, because in that one we are straight away making a connection and downloading the files. So what it is doing, it is using the application layer where you are using that program, and on the other hand you are using FTP server. This is your physical layer on the end. So what happening is that at this level they are actually interacting with each other on application layer. Username, passwords, whatsoever the status you will share there, and straight away these all other layers they bypass, and you can see they are just bypass and come to physical layer. It means that when FTP conversation is going on internet, something where you are just using the main, so there is other layers of internet protocol is already gone. We don't need that, because it's quite a direct to direct relationship in FTP one. Therefore we don't use other layers to communicate. From application layer straight forward to physical layer, and they start communicating with each other to download that file. So you can see that transport layer, network layer, data link layer, they are all gone. We are not using in FTP. You need to remember that in FTP these things are not used. Now coming toward the protocol headers. Let's say you are writing a letter to your friend in India from here, or to Spain or Japan somewhere. What you're doing, you're writing the name of the guy, that's one header. You're writing their street number, header number 2. You're writing their suburb area or where he's living, 3. 4 is city, 5 is country. At least you need 5 headers to write on the your parcel or your that envelope on top of it. Okay. So what happened, as soon as you put that parcel to your local post office, there's no let, okay, this is for Spain, they send to Spain, it reaches Spain. On the airport where their post office department is, they say, okay, this is already in Spain. They cross the letter of Spain because they know that they already there. Now they see which city, then they send to that city. It received that person in that city, they say, okay, it's already in that city. He never looked to the city then address, he looked to the next address inside that, which area in that city, he already there. So that is discarded, that header gone away. And then after that, city to area. When you are in that area, then you are looking for the street. When you are in that street, then you're looking for that house, and you reach there. These are the job of the headers. These things should be very much clear in your mind. Transport layer, always use the TCP header. We will go one by one on these one in the coming lectures, but as a summary, you should know that network layer works with the IP header, internet protocol header. Okay. Data link layer add an Ethernet header. So there are different headers which are on different layers working on. Now you can see that. See, this is your first header. Start from HTTP. What the example I gave you? Now it makes sense to you when I move forward. See, actually, please write down this thing. Application is equal to HTTP. Then transport is TCP, HTTP. Then you can see network is IP, TCP, HTTP. Then Ethernet is IP, TCP, HTTP. And then it is on physical layer. Is it transported to other country? This is also in your week 3 lectures as well, but please, when we are having a lecture, for every lecture at least you have a 1 page some notes in your notebook, which gives you idea that what you have done in that lecture and reminds you. Don't need to write everything because they are already there in these slides, but some of the things you know that what is important in that. So always make a habit to write down those things. So you can see that it is traveling, and then the same process follows oppositely. It goes up, the Ethernet goes, IP go, TCP go, and HTTP at the end received. Make sense? But again, remember the example of analogy of aeroplane. That's very important because it's going like that way, but they are actually communicating this way as well. Okay, but they're communicating like this way, but that information is going from there as well. So it's very hard to understand like how they can connect straightforward, but their communication should be go from there. So that's you need to understand. So that's what we have done up till now, week 3, and from next week, see topic 4 is data link layer, then topic 5 is network layer, transport layer, and topic 7 is physical layer. Every layer you should be on top level. You need to know where you are standing, where you are doing that job. Okay. Now coming to the lab, I will explain it. Yes. No, just explain it and then you do it by yourself at home. Okay, stop this one and then we